Hello everyone and welcome to another episode of Flawless Execution, a UNICOM Engineering podcast. I'm your host Daniel Litwin, the voice of B2B. Welcome to the studio and thank you so much for joining us on another conversation as we continue to explore major trends in our industry and important news that's reshaping not only our work but the larger ecosystem that we operate in. So thanks again for joining us, and before we jump into today's topic, I want to make sure that you're caught up on previous episodes and you catch all of our future ones. So make sure you're heading to our website, unicomengineering.com. Again, that's unicomengineering.com for more information on our solutions and services, the various industries that we serve, but also more content, including podcasts, videos, blogs, white papers, you name it. And you can also subscribe to Flawless Execution on Apple Podcasts and Spotify. So just hit that subscribe button and you'll have a full catalog of previous conversations as well as episodes that we drop in the future. You don't want to miss all of our thought leadership. So let's go ahead and jump into it, folks. On today's episode, we're going to be breaking down an exciting update out of Intel, and that would be the release of its whole new architecture, the 4th generation of Xeon Scalable processors. So here to get in the weeds and unpack this Intel processing solution as well as its impacts is our guest for the day. So I'd like to go ahead and welcome Mr. Austin Hypes. He's Chief Technologist and VP of Engineering at UNICOM Engineering. Austin, man, thank you so much for joining us here in the studio and for this episode of Flawless Execution. How you doing today?
Not too bad. Thanks for having me.
Absolutely. Love that you're repping the UNICOM swag. That's a nice shirt, man. And I appreciate you taking some time out of your day to walk us through this update because I'm sure folks in this world know the power of Intel's processors, of the Xeon ecosystem, but with each improvement, with each generation, there are a lot of specifics that are easy to identify, but also some maybe that are less easy to identify and really don't prove themselves until they're in practice and you actually see those processors doing their magic. So I want to unpack all of that here with you. So thanks again for joining us. So again, we're now at the 4th generation of the Xeon Scalable architecture. Will you give us some of the basic hardware features, right? Let's just break it down. What differentiates 4th generation from 3rd generation?
Sure, yeah, absolutely. So there's quite a few improvements just at the basic hardware level between 3rd and 4th generation. One of the first and most obvious is, of course, more general purpose cores. With the 4th generation scalable Xeons, you actually can have up to 60 cores per CPU. Of course, they scale down much lower than that, but compared to the 3rd generation architecture, that peak was 40. So quite an improvement in the amount of cores available. With that, and to help feed those cores, the memory architecture has been improved dramatically from a DDR4 architecture to a DDR5 architecture. So it's our first platforms in this next generation of general purpose memory. So, and also to help feed all that I/O into the platform, we moved from PCI Express Generation 4 to PCI Express Generation 5. PCI Express Generation 5 offers twice the speed per lane over Gen 4, and also with that came more PCI Express lanes available per CPU. So we're up from basically 64 lanes per CPU in the 3rd generation up to 80 lanes here in the 4th generation. So overall, a lot more horsepower available and the I/O to feed it.
And we'll break down the PCIe intersection here in a little bit too. But if we think about that hardware in practice, then are there any unique features to this 4th generation architecture that become possible with that increased horsepower?
Sure. So obviously anything dealing with high performance computing, hyperscaling, things like that, where you need to do very large workloads,
sure.
Spread them out quite a bit. Those all come into play. Some other additional things that were worked in on some of the versions of CPU, where actually all of them are now available with CXL 1.1 and 1.2, which is the Compute Express links. So this is kind of the next generation of PCI Express. It's not technically PCI Express, but is built on a foundation of PCI Express Gen 5. And it allows connections to things like network accelerators and GPUs where they can share memory with the system much more efficiently. So any of those add-in accelerator cards used in a lot of those high-performance computing type of workloads can have a more efficient path to the system's memory.
And I'm glad you bring up high performance computing and heavy workloads, because as we're seeing, that isn't a workload that is unique to any one industry nowadays. As we see more industries digitize their operations, get into smart systems, upgrade the network architecture, and begin to blend the IT and OT of their machinery, let's say on the shop floor. There's more edge computing, and more of that edge computing is high workloads. It's heavy workloads, and that means that this application is going to be immediately useful across many industries. So I'm curious if you can break some of those down, right? Where are you immediately seeing this next generation of the Xeon Scalable architecture be most useful, and why, right? How is it leading to results that prove that these improvements are worth it?
Sure. So a lot of industries can utilize the new hardware with its greater performance overall. We kind of mentioned HPC and hyperscaling when you're going to run a lot of workloads in more of an enterprise or cloud data center. But there's also specifics in the architecture that tailor towards different industries. When you talk more towards the edge, there's specific vRAN acceleration or radio access networks that are very common in 5G rollouts and infrastructure. So where in a previous generation architecture you might have had to use a special accelerator such as FPGA to meet the performance goals for those vRAN type of applications. Many of the CPU models in the 4th generation have elements of that acceleration built into the instructions, so you may no longer need that additional accelerator, letting you make a smaller, more energy efficient package. Beyond that, as we mentioned, there is going to be a wide range of CPUs available. So when you need to get down into more of that embedded long life space for more kind of industrial computing applications, that's there. Anything to do with networks and security, those are huge focuses and features that we'll get into some of the acceleration available on the CPUs. Those are things that traditionally have chewed up a lot of CPU cores when you try and use them general purpose. So a lot of effort has been put into accelerating those workloads without having to tax those general purpose cores nearly as much.
And then if you were to look ahead, right, where do you see this architecture just being sort of an initial stepping stone for future projects down the line, or potentially use cases that are hard to even fully imagine yet, especially in the UNICOM context?
Yeah, so as we look at the ecosystem around the 4th generation, Xeon Scalable, as mentioned, it has things like, CXL in it. There's also technologies being added into future releases of the CPU, such as HBM or high bandwidth memory, where you can have extremely fast memory actually embedded into the CPU package itself that can either be used instead of or supplement, the main memory in the system. So where these come into play is when you get into a lot of artificial intelligence and machine learning, places where accelerators are heavily used. CXL is going to allow for a lot more efficient use and connectivity to those accelerators like GPUs between the general purpose processor and those GPUs themselves. So like I said, artificial intelligence, whether we're talking about training or inference, moving that data around faster and more efficiently lets those workloads happen faster, lets the training happen faster, lets you run your models more quickly. But being the Xeon architecture, it means it's not specific and only useful for that. So when you're done with all that training and inference, it can be used for other things. That HBM or that high bandwidth memory that will be available in future releases is really good for machine learning and AI side, but it also is extremely good for things like in-memory databases. So where you need to process and analyze a lot of information in a database, very quickly. And high performance databases are used, everywhere. And whether it be high performance computing, whether it be in telecom infrastructure, whether it be in just more industrial type applications where there's a lot of manufacturing going on, as well as large scale websites, e-commerce, things like that, where you want to get to customer information very quickly. All that can be accelerated with this new architecture.
I want to highlight a few more sort of trends here that intersect. You brought it up earlier, but I'm curious how you see Xeon Scalable's 4th generation intersecting with and taking advantage of, or maybe even motivating more innovation around PCIe technology, or just more specifically PCI Express lanes and slots. We just made it through Generation 4. Now we're at Generation 5 of PCI Express. So as that's evolving, I'm curious, what is now this 4th generation of processing architecture able to take advantage of with evolutions in PCIe and vice versa too?
So yes, in the 1st and 2nd generation Xeon Scalable, we were on PCI Express Gen 3. Here with 3rd generation, we jumped to PCI Express Gen 4, which was a doubling of performance per lane. And now here, just a few short years later, we're on to PCI Express Gen 5, which is another doubling. So literally, we doubled and then we doubled again, within literally 3 or 4 years, which hadn't happened before. But part of the reason for that is all of this increase in networking, this increase in required I/O, this increase in needing to connect to accelerators. So as we look at what PCI Express is being used for today, it's the main connectivity to high performance storage. So the majority of high performance, SSDs, out there use NVMe. It's non-volatile memory express. That's PCI Express. So you need more and faster PCI Express lanes to feed this greater number of storage devices that are also higher performance. With that, we keep seeing increases in networking from the edge all the way through the backbone, where not too long ago, 1 gig was very common. Now, probably 10 gig interfaces are the most common when connecting to servers, but they're rapidly moving to 25 gig and 100 gig. And that means that kind of the top of rack switches and everything else need to go beyond that. So you're starting to get to 200 gig, Ethernet, commonly available now. Still somewhat expensive, but commonly available. And 400 gig is just emerging in the market. Well, to feed those interfaces, it requires a lot more bandwidth and a lot more lanes to get there. Hence, PCI Express Gen 5. Through that doubling of speed, I can now either do the same work with fewer lanes, so I can have more devices in, or I can use the same number of lanes to get more throughput through there as I move from 100 gig to 200 gig, and beyond. So, and then as we mentioned with the CXL side of things, that's really unique. And these are some of the first products to offer CXL, which is built on the physical foundation of PCI Express Gen 5, but adds these extra features really for memory access, so that everything doesn't have to be interrupted and go through those CPU cores when you got to move information from accelerators to the memory of the system. So creating that kind of fast path there really makes things more efficient and lowers the wait states, in the system.
And in that evolution from PCI Express 4 to PCI Express 5, what effect does that also have on platform life, right? Longevity and life cycles of the platform. And then where do you see that connecting with the Xeon Scalable architecture 4.0?
Sure. Yeah, so when we go all the way back to the 1st generation, 1st generation and 2nd generation Xeon Scalables were actually designed to be compatible in the same main system architecture. Basically meaning to go from 1st generation to 2nd generation was really just a CPU change. There were a few other minor tweaks in there. You got to run the memory a little faster and things like that, but those same motherboards and those same platforms that were designed for 1st generation were designed to seamlessly move into 2nd generation. With 3rd generation, when we got to PCI Express Gen 4, that was unique. For the first time in a very long time with Intel, it's kind of what we refer to as a one and done architecture, where this CPU and this series of servers / motherboards was unique. There wasn't a follow-on CPU designed to go into that same socket on that same motherboard. Now that we're at the 4th generation, it is designed to once again kind of go into a pair of architecture. So we'll have 4th generation now, and then the expected 5th generation, which will be out in the coming years, is being designed today to be compatible with that same architecture. So we'll get at least 2 generations of platforms with PCI Express Gen 5, and with that it'll be the same number of lanes, the same layout to utilize the same motherboard, so that as our clients and as customers move forward, they kind of have that midlife kicker. It's halfway through the platform life, they'll be able to start buying a next generation of Xeon to give them a little bit more performance, a bit more cores, and a bit more features.
You also mentioned earlier, and something else I just want to follow up on, this concept of acceleration, right? And a lot of the launch events and media releases around Xeon Scalable Gen 4, there's this theme of accelerate with Intel Xeon. Can you expand on why there's such a focus on acceleration, right? Like, what are we accelerating, and to what end, and for what purpose?
Yeah, absolutely. So somewhat unique now to the 4th generation. We talk about accelerators a lot, and most of the time in the industry when we're talking about accelerators, we're talking about another chip, that's not part of the processor to add additional functionality, whether that's a GPU, whether that's an IPU, whether that's an FPGA, but something else being added to the system to give you more performance and to offload work that would normally be done by the CPU, the general purpose. Well, now with the 4th generation, multiple versions of it are actually offered with built-in accelerators.
Oh, wow, okay.
Yep. So not every version has all the accelerators. They're kind of a mix and match, but different versions are tailored for different types of workloads. And with that, there's 4 main accelerators available in the CPU architecture. First, we have QAT, or Quick Assist technology. This is actually an acceleration technology that's been available from Intel for a number of years, but it's the first time it's in the Xeon Scalable product line. Normally, you'd have to add in like I said, another discrete chip to get this capability, where now you can get it built into the processor. And what QAT does is it allows for acceleration and offloading of encryption and compression. So AES encryption specifically, which is widely used in the industry for encrypting data, whether that be data at rest or data over the network. So being able to offload that from the CPU, that's traditionally been a CPU intensive workload. So now you can free up those cores to do other work while you use QAT to do that. And compression, same way, it's compressing data before it goes on a wire, makes it more efficient. Compressing data on the storage in your system makes it take up less space. A lot of times compression hasn't been as heavily used as people might like, because once again, CPU intensive. But now when I can run compression without having it tax my general purpose cores much, frees them up to do other work, lets me do that, plus it's better performance per watt than if you were to try and do that on the CPU cores themselves. Moving on, we also have IAA acceleration, which is in-memory analytics acceleration. This is a unique type of acceleration that's really designed, not exclusively, but really around in-memory databases. What it does is it speeds up the access and the analytics for in-memory processes like in-memory databases, and basically makes them faster, and you once again use less CPU cores. So any industry or application that utilizes databases and that becomes one of their bottlenecks, our lookups and things in databases, IAA can greatly speed up that, and once again lower performance per watt to do that work. We also have another one called DLB, or dynamic load balancing. This one is kind of an add to IOAT, or the IO acceleration technology that Intel's had for a while. And what it allows is when you have a lot of network streams, or more specifically, you have network interfaces that have a lot of data coming into them. DLB allows that processing of that network stream, of that incoming data, to spread across multiple cores. Traditionally, a lot of workloads, those were single-threaded, which get locked to a single core. So you might have all these CPU cores sitting idle or a low utilization, you have 1 or 2 or maybe 3 or 4, depending on how many network just spike to 100%. And so everybody else is just waiting on those cores to finish processing the data to move it to the others. This really allows it to spread out and utilize everything as effectively, and also means you might be able to run the CPUs at a lower frequency to save power. You don't have a few cores just going crazy while the others are kind of sitting idle.
Right.
The last one is DSA, which is the data streaming acceleration. And this, not to be confused with DLB, this is about accelerating moving data inside the system. So from things like that network adapter into the system memory, or the system memory into cache, or memory into storage, or storage back to memory. So it helps offload that work from those general purpose cores so that data inside the system moves better and more efficiently. And that one is actually considered so important by Intel that every Xeon Scalable has some level of DSA acceleration built into it. Now, depending on the individual CPU, the individual processor, it could have between what we call 1 and 4 engines, built into it. Yeah. But everyone has at least one, because that is an area that Intel identified as a huge bottleneck, in a system, is just too many wait states moving data around. So if you can accelerate that, why not put it in everything?
There's a few other layers of the architecture I want to pick your brain on. I've heard about Intel On Demand. I've heard about Intel Speed Select as layers of Gen 4 that are drawing a lot of interest and imagination for pros that are hoping to leverage Xeon Gen 4. So break those down, or any other layers that you think are worth noting here for our audience.
Sure. So when we talk about Intel On Demand, these are some new features being offered from Intel. So we talked about all these different accelerators available in the CPUs. And as I mentioned, not every CPU has every accelerator. Also, not every CPU has every accelerator possible enabled. So what Intel's done with certain specific versions of the CPU is they have Intel On Demand available. What this means is that particular processor comes with some of the accelerators enabled and others disabled, and you pay a lower price for that. But what it allows is, in the future, you can get basically a special unlock key specific for that CPU that you can add in and unlock those additional accelerators that are available for that specific model. So for customers that might not be utilizing this acceleration today, or might not need the full acceleration available, they might only need 1 engine, the CPU might have 4. It takes something like QAT for encryption and compression. You might not be doing workloads today that require a full 4 engines of QAT handling a couple hundred gigabits a second. Maybe you're only doing 20, 25, 34. 1 engine might be good enough today. But now you can scale that over time to say, now I'm doing more encryption, I'm doing more compression, it's become more complex. I can essentially buy a license to unlock the remaining engines in that particular CPU. And that's the same for all the accelerators we talked about. Now, where we talk about Intel Speed Select, that's a unique thing on once again, several of the models of CPU. It's not on every CPU, but different workloads and different licensing tailor their performance differently.
Yeah.
So several of the CPUs in the stack allow for selection of the number of cores enabled on that CPU, and with that, the frequency those cores can run at, and obviously the power they consume. So a single CPU might have 2 or 3 profiles available that vary the number of active cores, their frequency, and the power consumption. So what that means is that some applications don't thread, they don't scale as well once they hit kind of a certain limit. So it might be better for those applications to have a processor that has fewer enabled cores if each of those cores can run faster. Likewise, there are other applications as we get into, especially things like hyperconvergence, where I'm running a bunch of virtual machines, where the individual core performance might not be as important as the total number of cores available. So in situations like that, it can be retailored, through the configuration to offer more cores, typically at a lower frequency per core, but once again, overall more cores available. So once again, this is another way to tailor specific 4th generation Xeons to the workloads that they will be doing, and you could have potentially one hardware configuration that could be configured 2 or 3 different ways based on the workloads that are going to be done. Another place where that comes into play mainly for enterprises is certain enterprise software packages are licensed based on the number of cores utilized for it. So you might have a particular application that you might prefer to run fewer cores faster than having more cores run slower, simply because it might save you money on your annual licensing for a lot of these enterprise applications.
Right. I think that's about it here. I feel like we've covered just about everything. Is there anything we haven't touched on or any last notes you want to leave our audience with as they think about maybe how they would apply or take advantage of Gen 4?
Just, hey, UNICOM Engineering, we're a great Intel partner. Intel's a great partner of ours. We understand this architecture, very well. We have products being released, throughout this year, tailored to different workloads and different environments. So let us know how we can help you.
Austin Hypes, thank you so much for your time. Again, folks, we've been unpacking Intel's Gen 4 Xeon Scalable architecture. If you want to learn more about how it's being applied, how UNICOM Engineering is leveraging it for its solutions design and systems integration, make sure that you're heading to our website, unicomengineering.com, and make sure that you're subscribing to Flawless Execution, a UNICOM Engineering podcast on Apple Podcasts and Spotify. Again, we've been speaking with Austin Hypes, Chief Technologist and VP of Engineering at UNICOM Engineering. Austin, thank you so much for your time. And if folks want to get in contact with you or pick your brain anymore on the features or applications or potential results that could come from 4th Gen Xeon Scalable, how can they get in touch?
Yeah, best way is austin.hypes at unicomengineering.com, and we can get you directed to the right person that can help you out.
Lovely. Easy enough. Austin, thank you so much for your time. It's really been a pleasure.
Thank you for having me.
Of course. And thank you everyone again for joining us on another episode of Flawless Execution, a UNICOM Engineering podcast. Make sure you're subscribing on Apple Podcasts and Spotify for more. And again, head to our website, unicomengineering.com, for more episodes of the show and other important resources. I'm your host, Daniel Litwin, the voice of B2B, and we'll catch you on the next episode of Flawless Execution.